Hi, welcome to my video on the maximum or minimum point of a parabola. A parabola, f of x equals ax squared plus bx plus c, or it could be y equals ax squared plus bx plus c. This is the function notation, f of x. This is in terms of y. So I have a parabola drawn here. Notice that the parabola is going downward, and this is the peak point. And the peak point here is 2, 3. X is 2, y is 3. That's the vertex, call it V, of the parabola. And notice that this vertex is a maximum. So the vertex is a maximum because it's the highest point in the graph. And if we draw a horizontal line through that vertex, here's the horizontal line. The horizontal line is y equals 3. And the slope of the horizontal line, which is the slope of the tangent, the slope is 0. Any horizontal line has a slope of 0. So the tangent passes through the parabola at this point, which has a slope of 0. So what happens is that if we do the f or the g or the y, we could say the f of x, this is occurring at 2. The derivative at 2 is 0. 2 is the x value. And also, if we do f prime of x, where x is greater than 0, so the f prime is the slope of the tangent, and the slope of the tangent is positive greater than 0 when x is less than 2. So when x is less than 2, 2 is right here. Less than 2 goes this way. The slope of the tangent is positive. And f prime x is less than 0. That's when x is greater than 2. Less than is negative. So the slope of the tangent is negative on this side when x is greater than 2. And just notice, if you take this vertex right here, let's say that's the vertex here, and you draw like that and like that, on the left side you have a positive slope, on the right side you have a negative slope. So that means this point is a vertex, because f prime x is greater than 0 when x is less than some value, and f prime x that's greater than 0 when x is less than some value, say c, could be 2 as I have here, and f prime x is less than 0 when x is greater than some value for c. So that gives the maximum point. So let's look at this graph. Notice that this vertex here is 1, negative 1. So the vertex is 1, negative 1. Notice that this vertex is a minimum. I'm going to write MIM, minimum. Vertex is a minimum point. This is the lowest point in the graph. And again, if we draw a horizontal line through this vertex, the horizontal, just write down, horizontal line has a slope of 0. So the horizontal line has a slope of 0, and the horizontal line here is y equals negative 1. So that means that at the vertex, the derivative is the slope of the tangent. So at 1, the f of 1, we have a 0. And we see that if you do f prime x, if you take it on the right, if f prime x is greater than 0, that's positive here. That means that's when x is greater than 1. And f prime x is less than 0, and less than 0 is negative, and there's negative here, slope of any tangent at any point along this curve here. You draw a tangent, the slope of the tangent will be negative, and that's when x is less than 1. So to cap that, if a parabola has a vertex, let's say of c comma f of c, if that's the vertex of your parabola, then we have a minimum point if f prime x is less than 0 when x is, so this is a minimum. So it's f prime x is greater than 0 when x is greater than the value of c. And f prime x is less than 0 when x is less than c. So if we look at, again, I draw a picture, there's a minimum. So the f prime is the slope of the tangent. So the slope of the tangent on this side is negative, and that's to the left. And on this side, the slope of the tangent is positive, and that's to the right. And for, if the vertex is still this, what a maximum point is just the opposite. The f of x prime is greater than 0. So if we take the maximum, if the slope of the tangent is greater than 0, that's on this side. So that's when x is less than c. So if it's on the left and it's a maximum, you'll have a positive slope. And if f prime x is less than 0, that's right here, the slope is negative on this side, that's when x is greater than c. Greater than, put a greater than symbol here. So that's explaining the maximum minimum point in relation to the slope f prime. Greater than 0, less than 0. Let's work out a few questions. Number 1, if f prime x is less than 0 when x is less than 3, and f prime x is greater than 0 when x is greater than 3, and f prime of 3 equals 0, and we're looking at a parabola because the f of x is equal to ax squared plus bx plus c, that means we have a vertex at 3. Now we don't know what the value of y is, because if the vertex is at x is 3, that means, and the parabola, let's see, which way is it going? If it's less than 3, we have a positive. So let's say we take this point here. If it's less than 3, 3 is on this side, the slope is, again, the slope, be careful now, if at less than 3, which is on this side, the slope of the tangent is negative. So that means it's opening up like this, because the slope of the tangent is negative on the left side. And on the right side of 3, x is greater than 3, the slope of the tangent is positive. So that means it's doing that. So and this vertex could be anywhere as long as we have the x coordinate of 3. It could be anywhere up and down this vertical line. So it's, in this case, we have a minimum point, because it's, as you can see, again, on the left side the slope is negative, on the right side the slope is positive according to the derivative. Number 2, we got d of x equals ax squared plus bx plus c is a parabola, and we got the d prime of 2 is 0, so that means the vertex of the parabola is 2, because the vertex is the slope of the tangent at x equals 2. So we draw a graph and we put x is 2 right here. So how's it going? So when it's greater than 2, when it's on this side, that means the derivative is less than 0. So the derivative is less than 0, that means it's opening downward from the 2. And when x is 2. And the derivative, if x is less than 2, the derivative is positive. So that means positive is going like this. Now, remember, 2 is the x coordinate, so the parabola can be there's an infinite number as long as the x coordinate is 2. So that means, according to this, is opening downward, so we have a maximum point. And again, the maximum point, if it's greater than c, the derivative is less than 0. If it's less than c and we get greater than 0, the derivative is positive on that side. So notice on the left side, we got a positive slope. On the right side, we have a negative slope. And number 3, this is explain using y prime. Y prime is the derivative of y. So if this equation, and now it makes no difference what the equation is that the derivative of y prime, explain using the y prime, which is the derivative, y the vertex is the maximum point of this parabola. So the vertex is negative 1 and 2. So the vertex is negative 1 and 2. So if the vertex is negative 1 and 2, that means if this is the vertex, that means that the y prime is equal to 0 when x is negative 1, because that's the slope of the tangent. They're passing through one point. And y prime is positive, y prime is greater than 0 when x is less than negative 1. And y prime slope of tangent is less than 0. So the slope of the tangent is less than 0 on this side. So that's when x is greater than negative 1. So because we have this point, which is the vertex, and it's doing this and this, that's a positive and that's a negative. That means this is a maximum point. So the vertex is a maximum point. Again, a maximum point is on the left side, it's a positive slope. On the right side, it's a negative slope. And that brings us to the end of the video where explaining about maximum minimum point in relation to the derivative, which is slope of the tangent. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.